Okay, the same thing's happening that happened to me last time. Give me 2 seconds here. There we go. Okay, I found what I needed. So I'm going to start presenting. What is this doing? I swear this only happens with 5th hour because everything with honors works the first time beautifully every time. And the last time I presented to you guys, it was slow too. There it goes. There we go. Okay. So this assignment is directly related to what I'm going to assign for you guys tomorrow. And it's really the last part of chapter 15 and 16 that we've done. So normally in class, I would do this as notes with you guys and kind of walk you through it. So that's why we're going to do it this way. All right. So points that collectively make up the solubility curve, or points on the curve, represent saturated solutions. Now, a saturated solution, that was in your notes that I posted yesterday, has the maximum amount of solute that can be dissolved in solution at a given temperature. Points that are below the curve represent unsaturated solutions. Now, if something is unsaturated, it has less than the maximum amount of solute that can be dissolved. That's why it's under the curve. It's less than what that line is, so it's less than the maximum amount of solute. Points above the solubility curve represent supersaturated solutions. And the difference between the point above the curve and on the curve represents the amount of solute which will precipitate out. Supersaturated solutions hold more than the maximum amount of solute, and it's all dissolved. So because it's got that extra solute in it, if you disturb a supersaturated solution, it will recrystallize out of solution. I still need to show you that demo there for supersaturated. I have the solution here. I just haven't made a video of it yet, so I'll definitely put that out hopefully by tomorrow. Units for solubility curve. So when I'm talking about solubility curve, I'm really talking about this graph here. On this graph, it's showing you the solubility of all these different solids. So over here, we see the grams of solute per a given temperature there, okay? This is our units of the solubility curve. Grams of solute per 100 grams of water. So grams of solute per 100 grams of water there. So we're going to be using this solubility curve to help us answer our questions. I'm going to shrink this down a little bit and make it easier to kind of show as we go. So the first question is, what salt is least soluble in water at 10 degrees Celsius? So we'd go to our graph and we'd find 10 degrees Celsius. And you can see here where all these lines are intersecting at 10 degrees Celsius. The one that's least soluble is the one that's holding the least amount of solute at that given temperature. And that is this one right here. That line there is potassium chlorate. So the salt that's least soluble would be KClO3, or potassium chlorate. Which salt is most soluble is going to be the one that's highest up. at 10 degrees Celsius. And that is this guy up here, potassium iodide. So most soluble at 10 degrees Celsius is Ki, or potassium iodide. What is the solubility of sodium nitrate in 100 grams of water at 80 degrees Celsius? I'm going to kind of clean this up here, since we're going to keep coming back to it. There we go. All right, so the solubility of sodium nitrate in 100 grams of water at 80 Celsius. So whenever I give you a temperature, you always go to the graph and you find that temperature. Here's 80 degrees Celsius, and you see where it intersects with the substance given, which is sodium nitrate. So 80, and then here is sodium nitrate. So that comes all the way up here. So the solubility of it, or its saturation point, is where it intersects with that line. And I would say that's approximately, reading over there, about 144 grams. Now, these are approximate answers. You will see me kind of write like a little squiggly line on my key. That just means like you should be close to that. If you had 143, you're correct. If you had 145, you're correct. So there's some leeway with these answers because of the way that you're interpreting them on a graph. All right, I'm going to erase this again. Okay, now the next set of questions is asking what kind of solution do you have? Do you have a saturated, an unsaturated, or a supersaturated solution at those given temperatures? To answer those questions, you need to put a data point in at each one of those temperatures with the amount of substance given. So it's 50 grams of ammonium chloride. So I'm going to go and find 50 grams on the graph, and I'm going to put a data point at 15 degrees Celsius, at 50 degrees Celsius, and at 80 degrees Celsius. So here's 50 grams and 15 Celsius, 50 grams and 50 Celsius, and 50 grams and 80 degrees Celsius there. Now the substance I'm looking at is ammonium chloride. So I'm going to look at those data points in reference to the line for ammonium chloride. So here's the ammonium chloride line. The first data point is above the line. Well, up here, we said that points above the solubility curve represent supersaturated solutions. So our first solution there is going to be a supersaturated solution, because that data point is above the line. The next data point at 50 Celsius and 50 grams is on the line. Since that one is on the line, that is going to be a saturated solution. Points that are on the curve or on the line, we said are saturated. So that one will be saturated. And the third one at 80 degrees Celsius, so if we look at that one in relation to the ammonium chloride line, you could see it's under the line. Since it is under the line, below the curve, we will call that an unsaturated solution. Up here, it said points that are below the curve represent unsaturated solutions. So whenever you're asked a problem like what kind of solution do you have, saturated, unsaturated, or supersaturated, always put those data points on the graph, and then you'll be able to answer that question. On the line, below the line, or above the line. All right, I'm going to erase these now too, to make it easier for the next question. All right, so our next question there. What is the solubility of sodium chloride in 100 grams of water at 100 degrees Celsius? So it's just asking you for its saturation point again. I would find 100 degrees Celsius and then sodium chloride. So there's sodium chloride, and sodium chloride has a really flat line. It barely changes as you increase temperature. So sodium chloride doesn't really change in solubility very much as temperature gets warmer. Most substances really increase quite a bit with an increase in temperature. All right, so sodium chloride at 100 is right about there. I would say that's about 40 grams. Again, if you had 39 grams or 41 grams, you would not be wrong there. That's an approximate answer. Okay, once we get to the back of this, now we're dealing with problems that involve calculations. Okay, so on your homework that I give you guys tomorrow, everything that's in bold, again, is going to be calculation type problems. So that's kind of a way that you can figure out what kind of work you need to do there. All right. I'm just opening up the calculator on my phone here because I left my calculator in my room. All right, so the first question, at 50 degrees Celsius, how much potassium nitrate can be dissolved in 350 grams of water? There's going to be 3 different types of calculations we do with this. This one has a different amount of water. And by different, I mean it's different than what the amount of water is represented on the graph. The graph says it's per 100 grams of water. So whenever you have a problem like this where it's a different amount of water, we say that that is going to be a proportion problem. So if you have anything different than 100 grams of water, you know you're going to be doing a proportion problem. So what we're going to do here is we have to figure out how much solute dissolves in 350 grams of water when normally it's in 100 grams of water. So I need to find at 50 Celsius how much KNO3 can dissolve in 100 grams of water. So whenever I give you a temperature, you always go to the graph. So here's 50 Celsius, and then we go up and see where it connects with KNO3, and it's right here. And that is at 80 grams. So normally I can hold 80 grams in 100 grams of water. How much can I hold then in 350 grams of water? To calculate this, you're going to cross multiply. So 100x equals 80 times 350. I really apologize for my handwriting on this thing. It's not the easiest to write on. My handwriting's pretty atrocious here. All right, so 80 times 350 divided by 100 to get x by itself comes out to be 280 grams. So this one would be 280 grams of potassium nitrate. And again, this should just be close to that value there. If you read it as 79 grams, then you're going to get a different answer, a little bit lower. But again, it just needs to be close there. Make sure, though, that you're labeling your substance and your unit and the amount. And I will say there's no sig figs with this answer or these types of problems because you're reading off a graph. I never grade sig figs with the solubility curve type problems. All right, so that was one type of problem. We had a proportion, and it was a proportion because we had a different amount of water. Number 7 is a precipitate type problem. So a saturated solution of potassium nitrate is formed from 100 grams of water. If the saturated solution is cooled from 70 to 50 Celsius, how many grams of precipitate are formed? When you see the keyword precipitate, this is always going to be a subtraction problem. So this is going to be a subtraction type problem here. So what we need to do is we need to find the solubility at 70 Celsius and the solubility at 50 Celsius, and then we're going to subtract those two values. Our substance again is KNO3, potassium nitrate. So at 70 Celsius, KNO3 intersects right there, which is about 130 grams. So this would be 130 grams there. At 50 Celsius, we saw this in the previous problem, it connects with a line at 80 grams. So when I cool down the solution, it can't hold as much solute. And because of that, it will recrystallize or precipitate out of solution. So 130 minus 80 grams comes out to be 50 grams of KNO3. That's how much will precipitate out of solution. So when you see that keyword precipitate, that is going to be a subtraction type problem. All right, the next one here, number 8. At 50 Celsius, 8 grams of potassium chlorate is dissolved in 100 grams of water. How much more potassium chlorate must be added to make this solution saturated? So here our key phrase is how much more. When you see that phrase, that is also going to be a subtraction type problem. So I give you a temperature here again and a substance. Whenever you have a temperature given, you need to go to the graph and figure out the solubility of that substance at that temperature. So at 50 Celsius, I would go up to see where it intersects with the KClO line, KClO3, and it's right there. And that is at 20 grams of solute. So at 50 Celsius, I have 20 grams of solute. But I don't have 20 grams of solute in the solution. I only have 8 grams. So I'm like down here. I would need to add then 12 more grams to get it on the line to make it saturated. 20 minus 8 is 12 grams. So I would need to add 12 more grams of potassium chlorate to make it a saturated solution. So those are the 3 types of problems you're going to see. How much more is a subtraction problem. Precipitate is a subtraction problem. And a different amount of water, and by different, I mean different than 100 grams, that is going to be a proportion problem. Okay, so we're going to do one more problem here. It says at 80 degrees Celsius, how much potassium chloride can be dissolved in 225 grams of water? So this problem we can see is a different amount of water. It is not 100 grams of water. So that means it's going to be a proportion problem. How much potassium chloride can I dissolve in 225 grams of water? Normally, everything is per 100 grams of water. So in order to figure out what goes on top here above the 100 grams, I got to look at the graph, 80 Celsius, KCl. So I go up to the graph and I find 80 Celsius. Here's KCl. That intersects right here. That gives us 50 grams. So I can hold 50 grams of KCl per 100 grams of water. Now to solve this one again, we're going to go and cross multiply. X times 100 is 100x. 50 times 225 is 11,250. And to get x by itself, divide both sides by 100. And I get 112.5 grams. And my substance here was KCl, or potassium chloride. So I want to make sure that I label it KCl there. So on this assignment, or on your assignment tomorrow, you're going to see all these different types of problems. So it's good to have this assignment or this worksheet in front of you to help guide you as to what types of problems you're going to have there. Okay. I am going to go back And I'm going to stop presenting if I can. There we go. Okay. All right. I know that was a lot of information. Questions for me? Anything that you have a question on after looking at that? And you guys can either turn your mute buttons off and like talk, or you can type something into the chat bar too if you want to.